Hey guys, I'm Sun. I'm a privacy and security researcher, and you're watching the Privacy Guides. In today's episode, we are going to configure a hardened Raspberry Pi OS server. For those of you who don't know what a Raspberry Pi is a system on a chip computer that is essentially kind of the size of a credit card. So this has RAM, it has a CPU, it has Ethernet, Wi-Fi, Bluetooth. It essentially has everything we need to do pretty cool stuff, and it's based on an ARM architecture, which means it doesn't have this Intel ME stuff happening on it. So what you're going to need for today's episode is a Raspberry Pi. You're also going to need secure digital, is that SD card? Secure, I think that's what it is. Secure digital, so SD card, and I'm actually using a micro SD here. That's what we need inside of the Raspberry Pi, but I also have this little adapter thingy. That means that I can actually plug the whole thing into my MacBook Pro 2015, which, by the way, nostalgia moment, had an SD card reader built in back in the day. So if you don't have one of those, you're gonna need an external SD card reader. Next up, you're gonna need a power adapter. And by the way, the power adapter depends on which Raspberry Pi you have. This is a Model 3B. It's an older model. I'll have, by the way, affiliate links in the description for you guys to purchase this stuff on Amazon. When you purchase stuff through those links, I get a tiny commission that I'm even asking myself why I registered for that. But you know what? Maybe as the channel grows, this is going to make sense. So I'll put links to make your life easier. And I'll put links for the Raspberry Pi 4, which, by the way, has better performance when it comes to reading and writing stuff to the SD card, as well as networking. So, but this Model 3B will work fine. So on the 4, you need something with a USB-C port to charge. This here is a micro USB. The other thing that you guys really need to know is those boards need a power supply that is at least 3 amps. If not, you will get warnings that it is underpowered, and if it's underpowered, the CPU will throttle, so that's not the best. Next up, you are going to need an HDMI cable. Again, this has changed on the Raspberry Pi 4. On the Raspberry Pi 3B, it's actually a standard, I'm not sure if you guys are going to see this, but like a standard HDMI cable. And last but not least, I'm forgetting something. You'll need a USB keyboard. This is the official Raspberry Pi keyboard. It's a pretty nice little USB keyboard that is cheap, but essentially you need a USB keyboard that has a standard USB plug on it. And the last thing that I really recommend, but it's not necessarily mandatory, is a nice little case for your setup. This here is the Flirk. I would say flicker for some reason. It's a nice little case. It's made out of aluminum. And this part here, which is aluminum, actually acts as a heatsink. So it's a really amazing case. So I'll link all of that into the description. So for me to record today's episode, I am actually going to be using a small Camlink. I'm not sure if you'll see this in focus, but a Camlink HDMI record thing, capture card, I think it's called. So the setup is kind of interesting. So I'm going to be recording, I'm actually going to be using Quicktime actually to show you guys what the Raspberry Pi is outputting through HDMI. So let's hook things up. So so I'm going to be hooking this. Now I wish I had an overhead camera, but I don't. So let's just do this like that. So I'm plugging this in here, and then I'm plugging this into my Camlink record card. Then the power adapter, maybe I'll record a studio tour with the updated desk, but essentially I now have power on the desk. So this here will be plugged in to the Raspberry Pi when we're ready. And the USB port is essentially plugged here. Well, all of this stuff you guys know, so I'm sorry about this. Okay. Next up, we're going to want to flash our SD card with the latest version of Raspberry Pi OS. So I'm just going to plug it into my computer here, get that keyboard actually out of the way temporarily, and let's do this. So as usual, the reference material is published on sunknewton.com. I'll link to that in the description as well. The first thing we want to do is create an SSH key pair. So we're going to create an SSH key pair and use that to connect to the Pi. So this, you've probably seen that a million times by now on the series, but you want to go and create that .ssh folder if it doesn't exist. Then you want to cd into it. And then you want to run the SSH keygen command to generate that. Please look at those instructions. This is a really neat little command from OpenSSL to generate a random password. I've done all of this already. As we can see here, I have a Pi private key and a Pi public key, and I have the password to that. Super shitty password. This is a demo computer. Yours should be much more complicated, but I have this credential stored into my password manager. Okay, moving along. Yes, so we're now going to generate a here doc. This is really just a little helper function. It will create a little command that we can then paste onto the Raspberry Pi when the time comes to create the authorized keys file that we're going to use to connect to the Pi using SSH public private keys. Okay, now we want to download the latest version of Raspberry Pi OS Lite. As we're setting this up as a server, we don't want to have all of the graphic user interface stuff. So the Lite version is way better. It's also much smaller. I wish I had downloaded this beforehand. That is not smart, son of the past. Damn it. But hopefully there's not too many people downloading the file right now, so it should be pretty fast. Yeah, okay, good. So this shouldn't take too long. Okay, so we're gonna wait for this. The reason why I'm creating this episode while this is downloading is I think next episode, maybe the one after, I'm gonna show you guys how to set up a Raspberry Pi as a Borg backend or as a Borg server. And I'm also gonna show you guys how to run a VPN StrongSwan client on the Raspberry Pi so that we can take this little device and ship it to someone offshore, and then they just need to plug it in using Ethernet and the power adapter, and boom, it connects online, it punches through NAT, and we can then back up to it. So Raspberry Pis are actually really cool little devices. I also use them a bunch in the context of the Bitcoin mini-series that will be coming shortly. I like the idea that this here can have Bluetooth and Wi-Fi disabled, and it becomes a really nice little cold computer that we can use to do cryptography stuff on it. So a lot more content will come. And okay, a few seconds left to the download. Perfect. Okay, so download is done. The next step is we want to clone the Raspberry Pi OS Lite image, and that is what we have here. So let's just pop that open and unzip the file. So as you'll see, we'll have a file that ends by .image. This is a pre-built operating system that we can then flash onto the SD card. And the warning here is very important, so I'm going to even mention it here. Please read those steps carefully. If you do this wrong, you can actually override your main hard drive and essentially pulverize the hell out of your life, because then your computer will be kind of bricked. So this is a very delicate step. There might be more user-friendly ways of doing this, but if you follow through, it's actually a really efficient way of doing it. So I'll start by opening another tab here, and so I'll read through this warning. Do not run the following commands as is. Run disk util list to find disk ID of SD card to override with Raspberry Pi, blah, blah, blah. So if we run this here, we're going to see that there's a whole bunch of disks. So this here, this is the internal hard drive. As I've mentioned a few times in the previous episodes, this is my MacBook Pro 2015. And instead of running off the internal hard drive, which I use for everyday life stuff, I actually run an operating system off this. It's a Samsung T5 SSD hard drive. So this SSD hard drive will be actually disk number 2. So it's a 2 terabyte. So as you can see, this is that. And then disk number 4, we can see that this number 4 is a 16 gigabyte disk, and that is what I have. I'm using a 16 gigabyte SD card. So disk 4 is the ID that we're looking for. So as said here, this we just ran it, and we can see that we're on disk 4. This here is a command that will unmount disk 4. So as you saw, I replaced the number by n to make sure that you guys manually make sure that you're setting things up properly. The good news is, before doing this, just unplug all peripherals that you can. And in theory, it should be the last disk. So it's always going to be like the largest integer number here. So disk 4 is what we're looking for. If we run this, it will ask us for the password, shitty password, demo computer. And if this command does not work, which it actually never works on mine, I think it's because of how things are formatted, I then run it using this unmount disk argument. And again, disk 4, disk 4, disk 4, good, enter. And now the disk is being unmounted. Now the next step here is the step where we're actually overwriting the destination. That's the step that can really damage things. So always make sure that you run it on 4 if it's 4. So this is using our disk. Our disks are actually faster to write to. It's like one layer underneath in the stack. And now let's just look what we downloaded here. 1202, 1202. So yeah, they haven't published a newer version. So final check for 4, we're good, enter. So this here is now essentially flashing the SD card with the Raspberry Pi OS Lite image. It shouldn't take too long because the image is actually quite small. When we run it for the first time, it's going to expand the file system. Now, hopefully I'll be able to time things properly and show this to you guys. So yes, actually we can see here last time it took about 40 seconds. So we might have to do a tiny bit of waiting here. Actually, while I'm waiting, I'll just prepare this command here. Okay, good, perfect. Now this, again, disk 4, enter, and it's done. So what this means is that I now have ejected my little SD card, and that little SD card has Raspberry Pi OS on it. So I can remove the micro SD from the adapter. I can then plug it into my board. I'm actually using the little box here, so here is where it goes. And next up, I will plug in my USB hard drive. Actually, the next few steps will be on this. So what you're not seeing, unfortunately, because I don't have an overhead cam, is I have my keyboards here. It's kind of a mess on the desk. Okay, so plugging USB into the Raspberry Pi. Now I am going to open Quicktime. So that's kind of a hack, but it actually works pretty nicely. So I'm using Quicktime, which, by the way, has features to record the screen or record a movie, so you can actually plug a camera right in there. And what I've done here is I've set that to Camlink 4K. So what we're seeing here on QuickTime is actually a live feed from my Raspberry Pi. So let's plug in the Raspberry Pi. Okay, so Raspberry Pi has been plugged in. So as you can see, it is now booting. You guys can use any any TV actually that has an HDMI. Oh, as you can see here, it's resizing the file system, and rebooting. Jesus. So yeah, you can use your TV for this. It doesn't have to be this weird strategy here, or you can actually just use your computer's monitor if you have two. So I'm using an external one here and my Mac, so I could use my Mac for the instructions and a monitor for the Raspberry Pi. Okay. So let's see what's next. I'll put this here and look at the next steps. So the next step is we want to log in as Pi using the keyboard and change the password. So let's see. By the way, you'll hear my fans on my MacBook Pro going. I think this is a little intensive because I'm recording the screen and I'm live streaming a Raspberry Pi on it, and it's having a hard time. Okay. So default username is Pi, default password is Raspberry, enter. Now that we're there, we want to make sure that we override the default password. So this is done using the PASSWD command. So PASSWD, enter. And now we want to put a password here. So actually the current one is Raspberry, and then we're just going to put a password here. Okay, good. So that's been done. The next step here is we want to run sudo raspi-config. that's the command that we use to configure things. Now, if you guys are using Wi-Fi, and that's what I mentioned here, actually, I'm kind of stupid. I didn't plug my Ethernet cable. So I have an Ethernet cable. I'm going to do it through Ethernet as it's kind of simpler. And it's actually the best way if we are going to be sending this to someone offshore. They don't need to configure Wi-Fi, which has to be done in a similar way as what we're doing here. They just have to like plug it in. So it's kind of plug and play. And given it would be using Strong Swan in the context of the Borg backup, that means that it will punch through NAT like magic. So that's pretty cool. Okay. So we're not going to set up Wi-Fi, so we can skip step 6. But we do want to enable SSH. So if we go into interface options and we go into SSH, we can then say yes. And then we're going to hit finish and we're done. Okay. Okay. So if ever you're asked to reboot, you don't need to do that in the context of today's episode. Now, the next step here is we want to make sure that we know what the IP address for this is. So if I type IP and then now, by the way, I can see that what I'm writing here is very freaking small. I probably should have changed the resolution, but it wouldn't have been a good example. Anyways, sorry about that. Okay, so IPA will list the IP address. And as you can see right here, it's a little small, sorry about that. The IP address on my private network is 248, so 10.0.1.248, and we've enabled SSH. So what that means is we can come here, now let me switch keyboards, and we can attempt to SSH pi at 10.0.1.248, enter. And it should ask us to confirm, oh, actually, sorry about that. Little quirk, this computer is running my own Strong Swan VPN, and I also configured a kill switch, and I'll link to that episode in the description. So I have a kill switch going that won't allow me to connect, or actually, even more importantly, won't allow external devices to connect to mine. So it's a pretty hardened firewall setup. So what I need to do is I need to switch it to the trusted mode. Whoops, I have to run that as root. And then shitty password demo computer. And that means that now it's in trusted mode, meaning that things can connect to my computer and my computer can connect to other devices on the local network. So this will now work. By the way, I'll link to all of this in the description. If you haven't seen that, it's actually quite insightful. Mac OS ships with a firewall called Packet Filter, and it can be used to do pretty cool low-level stuff. That's discussed in that episode. Okay, so that's cool. Now it's asking me for the password, and that's the one that we configured and we're in. Okay, so from that point on, I can go about disconnecting the USB keyboard from my Raspberry Pi, as it is no longer needed, and we won't need that live feed that is making my fans go. So what I'm going to do here is I'm going to disconnect as well the Camlink 4K and the HDMI cable from the Raspberry Pi. That means that the Raspberry Pi now is essentially plugged into power and Ethernet, and that's it. You don't need other peripherals right now. Okay. And I'll put this here because we don't need to look at this. All good. Okay, so we're now connected. Next step is we want to make sure we create the .ssh folder. And now we are going to take that here doc that we created a few steps earlier, and we are going to run this on the Raspberry Pi. What this has done is it has created that file here, and that file will allow us to connect to it using SSH public private keys instead of password, which is not as safe. So we can then exit. I'll clear the terminal, and we can then reconnect using the -i /.ssh/pi syntax, and that will use our private key instead. And the private key is this here, so I can copy that, paste it here, boom, and we are in. Okay. Next up, by the way, Raspberry Pi OS is actually based on Debian. So if you've seen the episode on how to set up a hardened Debian server, steps from now moving forward are essentially the same because it is essentially a Debian computer. And since it doesn't have a graphic user interface and it is intended to be used in a headless way, meaning no screen, it is considered a server. Okay, so running this here is done in order to disable pi bash history, and we're then going to switch to root. As you see here, compared to the Debian episode, actually, we're using sudo. Sudo is installed by default to allow the Pi user to have root privileges on demand, which is something that we will disable in a second as it isn't very safe. Okay, so now we're disabling bash history for root. We are now going to create a password for root. I've done that here. By the way, you guys can use OpenSSL as usual to achieve a good random password. And next step up, we are going to remove sudo. So that's super important. Sudo is something that allows any user, anyone who can break in the context of the Pi user, well, that attacker can have root privileges. So that's not good. So we've uninstalled sudo, making things more secure. And we are now going to disable password root login. Actually, we're going to disable root login altogether and password authentication. That will only allow using that Pi private key, SSH private key now. Okay, next up, we will disable Bluetooth. So as this Pi will be used in a headless mode as a server, we don't want Bluetooth to be enabled because that could expose us to some vulnerabilities. And given we're not using Wi-Fi either in this context, perhaps you are, but this is configured using Ethernet, I can run this command to actually disable Wi-Fi. Next up, we are going to update all of the apt index files and then make sure that all packages have been upgraded. As you saw, Raspberry Pi OS releases are released once in a while. They're actually, there are frequent releases, but in between releases, for sure, some of the packages will have been updated, so it's good to run this. So we are going to run apt upgrade -y for yes, and this here will upgrade packages. As you can see, a bunch of things are being upgraded, so that might take a tiny bit of time here. Hopefully not too much. It says 2 minutes. If it's too long, I'll jump cut this to when it's done. Okay, so that took a while. Next up, we want to run apt install Vim. So I like using the Vim text editor. You might like using another one, but this is kind of part of my boilerplate setup when configuring a new device. All right, now that this has been done, I want to configure Vim using a .vimrc file. Next up, we want to set the time zone. So I'm setting this to Montreal time. You guys can use the link here to find the appropriate time zone for where you are. Now, this is done if the server is IPv4 only. So this Raspberry Pi will be connected to my home network right now, which is IPv4 only. If ever a network was IPv6 only, this would have to be configured in a dual stack mode. But okay, I'm on an IPv4 only server, so this here is what I am going to run. Now we need to install iptables persistent. That's a way for us to write iptable rules to the file system and make sure that they're loaded when the computer starts. Okay, next up, we are going to configure a bunch of iptable rules. So what happened here is I'm setting up some SSH brute force mitigation stuff here. Then I am allowing everything on the loopback interface and everything on port 22 inbound, and then establish a related inbound requests. And for outbound, I am allowing DNS requests, HTTP requests, NTP requests, HTTPS requests, and related and established connections. Now, given this is an IPv4 only setup, I am going to disable IPv6 in the firewall as well. But if you guys have a dual stack upstream network, you would want to run this chunk here instead. Okay, now we are going to exit twice, once from root and once from pi, and reconnect. That is done to make sure that we haven't locked ourselves out using the IP table rules. Next up, we want to switch to root. As you see, this time we're not using sudo. We're using su instead, which is a safer approach. And I will log in. And last but not least, we are writing those IP table rules to the disk or to the SD card, making things permanent. So there you have it. We now have Raspberry, well, I was going to say Raspbian, actually, that's the old name, a Raspberry Pi OS server running on this beautiful little chip here, meaning that this can be sent somewhere. Actually, yeah, no, this is next episode. Right now, it is bound to our network and it won't punch through NAT. So you know what? Stay tuned. Next episode is going to be interesting. We're going to be setting up a Strong Swan VPN client on it and setting up Borg to set this up as a Borg backend. All right, I'll see you guys soon. Bye.